What if you fell into a black hole? Imagine gliding through the vastness of space, coming upon one of the universe's most enigmatic phenomena, a black hole. These cosmic behemoths, known for their insatiable appetites, have long been subjects of intrigue, both in scientific and popular culture domains. But what would happen if you, either by sheer curiosity or unfortunate miscalculation, happened to fall into one? Let's take a journey into the heart of a black hole to discover what fate might await. A closer look at black holes. Before we dive in, it's important to understand what black holes are. At the simplest level, a black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. This is why it appears black. They form when massive stars undergo gravitational collapse at the end of their life cycles. The boundary surrounding a black hole is known as the event horizon. Once anything crosses this point, it is irretrievably drawn into the black hole. The approach: gravitational differences. If you were to approach a black hole, particularly a supermassive one of the first things you'd notice would be the extreme gravitational difference, or tidal forces, acting on your body. If your feet were closer to the black hole than your head, they would feel a stronger gravitational pull. This would stretch you out, a phenomenon often described as spaghettification. Essentially, you'd be elongated into a thin strand of matter. For smaller black holes, this spaghettification would happen well before you reach the event horizon. But for supermassive black holes, you might cross the event horizon intact before being stretched out. Crossing the event horizon, a point of no return. Once you cross the event horizon, there's no coming back. Contrary to some portrayals in movies or TV shows, you wouldn't be able to see the universe outside. Instead, all directions would seem to lead you further into the black hole. From the perspective of an external observer, like someone watching from a spaceship, you'd appear to slow down as you approach the event horizon, ultimately seeming to freeze at the horizon's edge. They'd never actually see you cross it due to the way gravitational time dilation affects light coming from near the black hole. The inevitable end: singularity. As you continue your descent, you'll inevitably be drawn towards the singularity. The singularity is the point at the very center of a black hole where gravity crushes matter into an infinite density. Our current understanding of physics breaks down here, so what actually happens at this point is a mystery. Some theories suggest that singularities might be bridges to other universes or wormholes to different parts of our own universe. However, these are purely speculative and not based on any concrete evidence. Hawking radiation, a slow dissipation. Stephen Hawking proposed that black holes aren't entirely black. Instead, they emit radiation, known as Hawking radiation, due to quantum mechanical effects near the event horizon. Over an unimaginably long time, a black hole can evaporate through this process. But don't rely on this as an escape plan. It would take longer than the current age of the universe for even the smallest black holes to evaporate completely. While the thought of falling into a black hole is terrifying and fascinating, it's worth noting that there's currently no practical way for humans to get anywhere near a black hole. The nearest known black hole is over 1,000 light-years away. Moreover, the intense radiation surrounding young, active black holes would be deadly long before one reached the event horizon. Still, black holes remain a tantalizing frontier in our understanding of the universe, challenging our perceptions of space, time, and the nature of reality itself.